Good morning, everyone. Today's topic is the basic laws. So, here we are going to discuss Ohm's law and KCL, which comes under the subject electric circuit analysis. So, let us start with the Ohm's law concept. So, this law is an important law in electric circuits. It forms a major role in all kind of electric circuits. And here, the Ohm's law it can be taken within a passive element. The passive element is a model resistor. With respect to the resistor, we have got this particular formula, this relationship. Based on this relationship, we have got the definition as the voltage across a resistor, which is a potential difference or voltage, is directly proportional to the current moving through the entire resistor. So V of t can be written as R into I of t. So here V of t is directly proportional to the I of t, and it is related to the constant, which is the resistance of a particular material. And here, based on the polarity, we have included a sign. Either it can be a positive sign or a negative sign, but however, it is a bidirectional device. The another form of definition is completely based on the relationship between the parameters. So here it can be considered as the ratio of the potential difference calculated across the resistor model, which is called as a voltage. The ratio of voltage to the current at a constant temperature is always a constant, and that constant is a resistance. So the Ohm's law can be carried out for the resistor model with the condition. The condition is a constant temperature. It is more important. Now let us have the relationship. So here the relationship can be taken with respect to the graph characteristics. It tells about the relationship between the voltage and current. So here it forms a straight line. So what does the straight line means? It is nothing but the V of t is directly proportional to I of t, and it is a constant which can be represented with a property called as resistance. So according to this graph, what we infer here is whenever the V of t increases, the current also increases. Whenever the voltage decreases, the current also decreases. So it completely depends upon the voltage. So it forms a straight line relationship. And the model used here is the resistor, and it produces a property called as resistance. So now let me come to the concept of resistor. Resistor is a passive element, and the corresponding unit of resistance is ohms. So here the resistor, for the resistor we can able to calculate the resistance property with the formula R is equal to rho into L divided by A. So here the property of the resistance, it depends upon the several factors. So the major factors are, one is that it is directly proportional to the length of the conductor, which can be calculated in meters. So whenever the length of the conductor increases, automatically the resistance also get increased. And the length of the conductor decreases, again the resistance it decreases. Similarly, it is also inversely proportional to the cross sectional area, which can be calculated in meter square. So these parameters plays a major role in calculating the resistance of a material resistor. Apart from that, it also depends on the factors such as a temperature. So at a constant temperature, we can able to calculate the resistance as well as the type of material. So that plays a major role in estimating the value of resistivity in a particular resistor. The another concept is the conductance, which is the reciprocal of resistance. So and it can be expressed as G is equal to 1 by R, and the corresponding unit is mhos. So it can also be calculated with the relation Siemens. So it is a simple circuit where we connect a voltage source with a voltage of 115 volt, and it has a resistance value of 100 ohm. So it is directly connected with respect to the resistor, and we can able to apply the Ohm's law, which forms the basic law of this particular electric circuit, and we can calculate it based on the formula. Based on the formula, we have got the result as 132.5 ohms. So this is a simple calculations. And the property of the resistance, which is the resistivity, which can be calculated based on the type of a material. So as far as considering about the material, it matters. There are three types, three categories. One is the conductor, the second one is a semiconductor, and third one is the insulator. So based on the type of the material, we can have a different variety of resistivity, and based on that, it produces a resistance of a particular material. So if you consider a conductor, for example, if it is a gold, it produces a resistivity of 2.5 into 10 to the power of minus 8. And for a semiconductor, if it is a germanium, it can have a resistivity of 447 into 10 to the power of minus 2. And for the insulator, for example, if you consider a Teflon, it would be 3 into 10 to the power of 12 resistivity ohm. And the second concept is KCL. So KCL, it is another important and basic law for an electric circuit, with which we can able to track the voltage concept and current concept in the particular circuit network. So these plays an important role in estimating the voltage and current calculation for a complex circuit. So KCL can be categorized with respect to KVL law and KCL law. KVL stands for Kirchhoff voltage law and KCL stands for Kirchhoff current law. So now let us start with the Kirchhoff current law. So the consequence here is the sum of the current entering a node equal to sum of the current leaving the node. For any kind of network, we have a common junction point. This common junction point is called as node, and with respect to node, we can have the incoming current as well as the outgoing current. So it can be represented in a diagram with the arrow mark. So the arrow mark represents the entering current as well as the leaving current. So if you consider the entering current, here the currents are IA and IB, and for the leaving current it is IC and ID. So according to the concept, the sum of entering current is equal to sum of the leaving current. Therefore, the formula could be IA plus IB is equal to IC. It can also be expressed in different manner. The concept is the algebraic sum of current entering a node is equal to 0. So the total current is equal to 0. That is IA plus IB minus IC plus ID is equal to 0. And finally, the delta star conversions. So here we can have a two concept. One is the delta network, another one is the star network, and we can have a conversions. So these are the techniques which can be incorporated in electric circuits in order to reduce the complexity of an entire network. So this can be applicable to a part of a circuit. It cannot be used for the entire circuits. So while doing a conversions, we can make use of these formulas, so to reduce the complexity of a particular circuit and to achieve the desired results. The another application is the nodal analysis. It completely based on the KCL concept. So what is KCL concept? It is all about the current entering and current leaving. So with respect to the node, we can able to calculate things. And these problems related to KCL, by the concept of KCL, we can able to introduce the entering current and leaving current, and based on that we can